Now let's talk about the meniscus. A meniscus is the curve you see at the surface of a liquid in a container. We always read the volume at the bottom of the meniscus to ensure accurate measurements. Here's an example of a properly read meniscus in a beaker. We should always take readings at eye level to avoid parallax errors. First, let's define what we mean by stock solution and a dilution. A stock solution is a concentrated solution from which we make a diluted solution by adding salt. In this example, we will dilute a stock solution of copper sulfate to a lower concentration using this formula.
Using the Moore pipette, we delivered the stock solution into the 25 milliliter volumetric flask by measuring final minus initial. Our initial value here is 7.38 milliliters and our final is 2.43 milliliters, leaving us with a volume delivered of 4.95 milliliters.
The stock dilution is related to the first dilution using C stock times volume stock equal C dilution times the volume of dilution. In this case, the volume of our concentration of a stock would be 0.020 mol per liter and our volume stock is 4.95 ml. Our concentration of the dilution is unknown and our volume dilution is 25 ml. Using math, we find that our concentration for the dilution is 3.96 times 10 over minus 3.
So the main point of a dilution is to adding a solvent such as water, in this case it is water, to your solute, which is our copper amine. So we're going to add our water to our copper amine, reduce the concentration. Look, zoom in at the meniscus. The meniscus should be about the 25 milliliter mark, like it is right here at the bottom of the meniscus is what you're trying to measure. It's currently at the 25 milliliter mark, so it's good. Okay, now we're inverting the flask and gently mixing it.
Once your dilution is complete, it is important to clean your lab space properly. Make sure you dispose of any waste properly and make sure you keep your lab area clean. That's how you're cleaning up those things.
So this is how we found the molarity of each data point. For our stock, we use the grams of copper pentahydroxide that we delivered, which is 0.125 grams, divided by the molar mass, multiplied by the amount of the volume of the solution, and then we convert that into liters, and we get the molarity of our stock solution to be 0.2000. For the dilution, we're going to use our stock solution, which is at 0.020 grams over liters, not grams, moles over liters. And we're going to put that into our CV equals CV equation, which is our dilution equation. So we have our stock initial value times our volume delivered of stock, which is 12.01 milliliters, equals an unknown amount of molarity times 25 milliliters. So we're going to get a molarity of our first dilution of 9.608 times 10 to the negative 3.
Thank you for watching this tutorial on dilution. Now that you've seen how it's done, you can apply it to your own chemistry lab. Don't forget to check your calculations and to reserve your accurate data for the best results.